Hi guys, so this is part 2 of probability. In this tutorial, I'll discuss the conditional probability and permutation and combination involving probabilities. So let's begin with conditional probability. Let's say I had dependent events, and in dependent events, the probability of A intersection B would have been equal to, let's say probability of B times probability of A given that B. So the first event is B and then it is being followed by event A, for example. Okay, so this is the conditional probability of A given that B has already occurred. And you can look at the equation, and probability of A given that B would be equal to probability of A intersection B upon probability of B. So conditional probability is probability that one event occur slash, which is read as given that another has already occurred. This is equal to probability of both occurring divided by probability of the given event. So for example, probability of A slash B would be read as probability of A given that B has occurred, and this would be equal to probability of A intersection B divided by probability of B. So for example, in this question, Fabio drinks coffee each morning. He chooses these three flavors: Americano, Cappuccino, and Latte, with probabilities of 0.5, 0.3, and 0.2. So, if I were to draw a tree diagram for this, there are three possibilities initially. Either he can go for this, or he can go for cappuccino or latte. The respective probabilities are 0.5, 0.3, and 0.2. If he chooses Americano, he either drinks it immediately with probability 0.8 or leaves it to drink later. So there are two options now. Either he drinks immediately or later, and same cases for all. That's the second event. So if he chooses Americano, he drinks it immediately with a probability of 0.8. Okay, if he chooses cappuccino, he either drinks it with a probability of 0.6, and if he chooses latte, he drinks it immediately with a probability of 0.1. So you can fill out the rest of the probabilities. This would be 0.2, this would be 0.4, and this would be 0.9. Now in the first part, you are being asked to find the probability that Fabio chooses Americano and leaves it to drink later, which is this branch. So probability of A intersection L, which will be 0.5 into 0.2, 0.1. Similarly, Fabio drinks his coffee immediately. So you are being already given that Fabio drinks his coffee immediately. You need to find the probability that he chooses latte. So this is the conditional probability. Probability that he chooses latte given that he drank immediately. So there will be an intersection between drinking latte and drinking it immediately over probability of drinking immediately. Now in such questions for conditional probability, when you have a tree diagram, it's advisable to draw deal with the denominator first. So denominator which is this. Drinking coffee immediately. So either he can drink this flavor immediately, Americano flavor immediately, or cappuccino immediately, or latte immediately. So these are the three branches that makes up your denominator value. So the probability of each would be 0.5 times 0.8 plus 0.3 times 0.6 plus 0.2 times 0.1. Now the numerator will always be a part of your denominator. So probability of L intersection I means probability of choosing latte and drinking it immediately. So 0.2 times 0.1. So this comes out to be 0.333. Let's look at another example. Jody tosses a biased coin and throws two fair tetrahedral die. The probability that the coin shows a head is 1 over 3. It's a biased coin. So if the probability of head is 1 over 3, then the probability of tail would be 2 over 3. Each of the dice has 4 faces, number 1, 2, 3, 4, since it's a tetrahedral die and it's a fair dice, which means that the probability of 1 occurring, 2 occurring, 3 occurring, or 4 occurring is same. Jody's score is calculated from the numbers on the faces that the die lands on as follows. So this is the rule that they are having to calculate the score. If a coin shows a head, the two numbers on the dice are added together, and if it shows a tail, the two numbers from the dice are multiplied together. So let's look at the possibility space diagram if a head occurs and if a tail occurs. So the possibility space diagram is for the tetrahedral dice. These are the outcome for the first die and the second dice. Similarly over here. It's just the different way of calculating the score. The question says that if a coin shows a head, you add the two numbers, and if it shows a tail, you multiply the two numbers. Alright? So the probability of having a head, the possible outcomes of having a score after getting a head is as follows. And similarly, if a tail occurs, the product would be alright. Now you need to find the probability that a coin shows a head given that Jody's score is 8. It's a conditional probability. You want to find the probability that it's a head given that score is 8. So since it's a conditional probability, the denominator will have probability of score is 8, and the numerator would be the intersection of having a head and the score is 8. Now you need to carefully understand this question. Okay, so let's look at how can we have the score of 8. We can have a score of 8 when head is occurring over here, and we can have a score of 8 when tail occurs on the coin. ठीक है. So let's deal with the denominator first. Since we have a biased coin, the probability of getting a head and a score of 8 would be 1 upon 3 times 1 upon 4 times 1 upon 4. 1 upon 4 is the probability of getting a 4, and or what you can also do is you can write 1 upon 16, because that's one outcome out of 16, and times the probability with head, which has a probability of 1 over 3. Or you can get a tail and get a head. So there are two options. The probability of getting a tail is 2 over 3, and the probability of getting a score of 8 is 2 over 16. Okay. Now in the numerator you want a probability that head occurs as well as the score is 8, so which is this thing. So 1 over 3 times 1 over 16. So the conditional probability can be calculated as through this, and it comes out to be 1 over 5. You can work this out. So let's look at this example. When Don plays tennis, 65% of his first serves goes into the correct area of the court. So when he does the first serve, there are chances that either the serve goes into the correct area or doesn't go into the correct area. And there is 65% chance, which means 0.65 probability that the first serve goes into the correct area. Hence 0.35 is the probability of the first serve not going into the correct area. If the first serve goes into the correct area, his chance of winning the point or not winning the point, there are two outcomes. So the chance of winning the point is 0.9 and the chance of not winning the point is 0.1. If the first serve does not go into the correct area, so he will be given a serve again, so he will reserve. Now even in the second serve he will be given there are two chances, either the serve goes into the correct area or it doesn't goes into the correct area. So his second serve has a probability of 0.8 to go into the correct area, so 0.2 will be the probability of not going into the correct area. If the second serve goes into the correct area, obviously he will have two chances, either he will win or he will not win. So the probability of winning is 0.6, therefore the probability of losing would be 0.4. And if both of the serves are not going into the correct area, then he is losing for sure. So no arguments on that, he will lose the point. You in the first part you had to draw a tree diagram to represent this information. This is the tree diagram that you are required to draw. For the second part, you need to find the probability that Don loses a point. So probability that Don loses a point. So he can lose a point in these many ways. Either his first serve goes into the correct area and he still loses a point, or his first serve was not right, his second serve went into the correct area but he still loses a point, or both serves went wrong and he loses a point. So 0.65 times 0.1 plus 0.35 times 0.8 times 0.4 plus 0.35 times 0.2 times 1. So the probability comes out to be 0.247. Alright. In the third part, you are being asked to find the conditional probability that Don first serve went into the correct area, given that he loses his point. So you need to find the probability that first serve was correct, given that he loses a point. So this would be equal to the probability of intersection between the first serve correct and he loses, and in the denominator the probability of he loses. So in the previous part you just calculated the probability of him losing a point, that is 0.247, and the denominator was made up with these three branches. these three highlighted branches. Now remember this, that the numerator will be a part of these branch. So you want the intersection between serve going into the correct area and still losing. So the first serve going into the correct area. So the first serve went into the correct area and he loses. So that's the blue one. So 0.65 times 0.1. So the answer comes out to be, you can calculate this, the answer comes out to be 5/19. Yeah. Alright, so you can also expect to get probability questions that involve permutation and combination as well. So this is an example. A committee of 5 people is to be selected, okay, the word selected, from a group of 5 men and 6 women. What is the probability that committee contains 2 men and 3 women? So first of all, let's find out the number of ways of selecting this group, selecting 2 men and 3 women. So 5C2, these are the ways in which men can be selected, and you can choose 3 women from 6. Okay, 5C2 into 6C3, there are 200 ways. But if you were asked to find the total number of ways in selecting randomly 5 people without any restriction, so selecting randomly 5 people out of 11, the group contains 11 people and you have to choose 5 people. That's without any restriction. 462. Now the probability of having 2 men and 3 women would be 200/462, which is 0.433.